Good day, friends. You are welcome to ASC's Online Math. As we've promised earlier, we shall be dealing with SS1 General Math. And our first topic there is number-based system. And if you are watching this video for the first time, please make sure you do what? Follow us on our YouTube channel. Let's start. Number-based system. There are some tips that we need to actually understand before we go into detail in these areas of study. You know, we have a series of numbers. When we started from our primary one, we started with ONE 1, TWO 2, 1, 2, 3, 4, 5, 6, and so on and so forth. We counted them to uncountable number. But if you notice that when we started counting, we started with 1, right? Now let's say we start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so 8, okay, 8, 9, 10, and so on and so forth, like that. But if you take a look at this, from 0 down to 9. Now look at 10. 10 is generated from where? From 0 and 1. So we can categorically say that all these numbers, there is no number in this world that you want to generate that will not fall within these numbers. They combine these digits to form numbers. Call any number. We are going to generate it from this 0 to 9. That is number one tips for you to know. Now let's move on. So, number in their different bases, they have names. Number in their different bases, they have their name. Number base, maybe base 10. Let's start from base 10, base 2. Let's go to base 2. We call base 2 binary. Any number in base 2, we call them binary numbers. Any number in base 2, we call them binary number. This is the general name for base 2 numbers. Let's go to base 10. Base 10, when we have base 10, we have denary. We have denary number. Any number in base 10 are called denary numbers. Likewise, we have 12 as well. We have 12 to be duodecimal. Duodecimal numbers. Okay, that is the name we call any number in base 12. And also we have let's go to 16. We have that as well. Base 16, we have hexadecimal number. We have many of them like that, and so on and so forth, We have many of them like that. But let's pick them one after the other, and we shall be dealing with them. Their nature, how would you be able to understand or to identify a particular number in their base? Now, let's go to base 2, binary. Now, any number that is called base 2, okay, any number that is called base 2, no digit in base 2 number that is up to 2. What do I mean? These are the number you can find in base 2. Examples are, let's say 1, 0, 1, 1, 0. Okay, the highest number you can find, highest digit you can find in base 2 is 1. No digit here must be up to 2. And to identify this properly, they put what? 2 here at the subscript end of the last digit. You can see this is base 2 number. This is an example of base 2 number. Also, we have many of them like that. We can have 0, 1, 1, 1, 1, base 2. We have 1, 0, 1, 1, 1. In fact, we have decimal. Those with decimal as well. Dot 1, base 2, and so on and so forth. But in this area of study, what do we do generally? What do we normally do generally from here? Now, we shall talk about how we can convert base 2 number to any base. Base 2 number to what? To any base. Now, let's go. Let's take an example. Let's pick an example that we should express 1001 base 2 in base 10. This is very simple. In fact, it has been introduced to us starting from a JSS 2 class, how we can actually express any number in base 2 down to base 10. This is a very simple way. How do you express that? Now, if you have been given this 1001 base 2, okay, the only way for you to do this, and a very simple way for you to express it in base 10, is to expand this number with respect to the base. The base is 2. Then we shall expand it. Let's expand it. That is 1001 base 2 can be expanded as 1 times, look at this base. This is the first digit. 1 times 2 plus 0 times 2 plus another 0 times 2 plus 1 times 2. This 2 is what we are using to multiply each of these numbers in their position. Now, we shall start putting them the power 0, 1, 2, 3. Okay? Then let's simplify it further. 1 times 2 raised to the power 3. 2 raised to the power 3 is 2 times 2 times 2. That is 2 times 2 times 2, which gives us what? 2 times 2, 4 times 2, 8. Please, 2 raised to the power 3 is not 2 times 3. So therefore, 2 raised to the power 3 is 2 times 2 times 2, then which is giving us 8. Therefore, this is 1 times 8. 1 times 8 gives us 8 plus 2 raised to the power 2 is 4. Then 4 times 0 gives us 0 plus 2 raised to the power 1 is 2. That is 2 in one place. Okay, that is 2. Then 2 times 0 gives us 0 plus 2 raised to the power 0. Anything raised to the power 0 is equal to 1. We shall prove that to us when we get to other areas of study as well. We can prove it to us here as well, but 2 raised to the power 0 is 1. Anything raised to the power 0 is 1. Then 1 times 1, we have 1. Therefore, when we add everything here together, it gives us 9, and 9 is in base 10. So this is how to express or to convert binary number, that is base 2 number, to base 10. If you are very clear with this, if you understand this, express this in base 10 as well. Then make sure you drop your comments into the comment section. Like us on our YouTube channel. Make sure you follow us. And I shall be expecting your solution to this question. Bye for now. Peace out.